In the previous video, we calculated a new position for our character using the HumanIK full-body IK solver. Another way to expand our character's set of animation clips is by using the HumanIK retargeting solver. The retargeting solver lets you transfer animations from one character to another, even if their body proportions or skeleton structure are different. In this video, we'll explore the retargeting process, as well as best practices for memory optimization, applicable to both retargeting and IK solving. The retargeting and IK solving processes, though different, share a similar data flow and use many of the same functions covered in the previous video. Retargeting requires two characters, a source and a target, that you initialize separately to create the following components. Two HIK character objects, one for each character to represent, two HIK character state objects to contain each character's FK pose, two HIK property set state objects to determine each character's retargeting configuration settings, and a blank HIK effector set state object for the target character only. There is no need to create an HIK effector set state object for the source character, since the retargeting solver only needs its FK pose, which is stored in the HIK character state object. You'll first need to update the source character's HIK character state object with its current FK pose from the game engine. For this, you can either call the HIK setNodeState TQSFV function for iterative updates, or use a dataset to synchronize multiple nodes at once. Refer to the previous video for more specifics on this function and dataset. To properly transfer this FK pose from the source to the target character, the retargeting solver actually needs the help of the IK solver to carry out the necessary calculations. These calculations range from adjusting the position and rotation of each of the target character's joints to setting retargeting properties and constraints. To decide what the IK solver should calculate, you determine its solving steps by calling the HIK setSolvingStep function. Next, you need to set the target character's HIK property set state object to configure how the retargeting solver should project the transferred pose. For example, you can configure the reach, pull, and resist settings for several of the target character's nodes. You're now ready to launch the retargeting solver by calling the HIK solveForCharacter function with the following arguments: pointers to the HIK character, HIK character state, and HIK property set state objects for both characters, and a pointer to the blank HIK effector set state for the target character. The retargeting solver carries out three main operations. It copies the orientation of all nodes in the source character's HIK character state object to the target character's HIK character state object. It updates the target character's HIK effector set state object using the reach, pull, and resist values stored in its HIK property set state object. And it calls the IK solver to calculate a new pose for the target character based on the components you provide. The retargeting solver stores the generated FK pose in your target character's HIK character state object. From there, you must retrieve this pose using the HIK getNodeState TQSFV function and apply the result back to your character in the game engine. Keep in mind that you must repeat this retargeting process at every frame. Now that you know more about the IK solving and retargeting processes, let's focus on ways you can free memory resources and decrease CPU consumption of HumanIK at runtime. An easy way to be more efficient is to destroy the initialization objects when you finish using HumanIK for your characters. Use the following functions to delete the corresponding object. For each function call, you must provide a pointer to the desired object and to a memory deallocation callback function as arguments. In part 1 of this video series, we allocated memory for each HumanIK object that we initialized using a standard malloc function. Alternatively, you can optimize performance by allocating these HumanIK objects within continuous blocks of memory. Consult the HumanIK documentation for more memory management information. You can take advantage of HumanIK's multi-thread support by moving the solving processes to separate threads apart from your main game thread. Another way to reduce CPU costs and get faster performance is by using the low level of detail (LOD) implementations of the HumanIK solvers. You can easily swap between the full quality and low LOD solvers by simply substituting their respective launch functions. The low LOD IK solver saves costs by compromising on certain solving steps. Generally speaking, it uses faster but less precise methods of calculating the positions of your character's joints. It ignores a character's foot and hand contacts, the position of its fingers and toes, as well as certain effectors like its knees and elbows. It also disables the pull constraint necessary to obtain a full-body IK solve. Despite these limitations, you can use the low LOD solvers in situations where these small inaccuracies won't be noticed, such as when your character is within a crowd or far away from the camera. You can also use low LOD solvers to control non-playable characters, or NPCs, while you use a full-quality solver for your main character. When you set the solving steps for the full-quality IK solver, consider solving only the necessary limbs based on your character's motion. For example, if you only animate your character's upper body, you can reduce CPU consumption by specifying a subset of the entire solving steps instead. When you launch the full-body IK solver by calling the HIK solve for effector set function, the solver actually calls a set of smaller functions to carry out the different operations required to calculate a new pose for your character. In cases where you cannot call the full IK solver function due to limited memory space, like on a PlayStation 3 SPU, you can instead call these functions individually. Note that to use this alternative method, you must keep in mind the following limitations. Before you call any one of these functions, you must first call the HIK solve for effector set begin function. Since each of these functions affects specific body parts, you must ensure that you also activate the corresponding IK solving steps. For example, if you intend to only solve the position of your character's fingers, you must include the IK solving steps for his hands. You cannot call these functions to control the IK solver during the retargeting process. For this, use the IK solving steps instead. Lastly, you cannot combine these functions with the low LOD solvers we looked at earlier. After you've performed these optimizations, you can use a performance profiler to analyze your runtime CPU usage and identify the portions of your code that are the most resource-intensive in your game. From there, you can streamline the structure of your algorithms to fix any performance bottlenecks. This wraps up this overview of the different ways to use the HumanIK solvers to control your character at runtime. You can use the knowledge garnered here as a springboard to further your own game engine integration and create custom functions to suit your needs. If you experience problems using HumanIK, don't hesitate to call Autodesk support.